stars can't fuse past iron. Well, then how's the rest of the table? How are all of those heavier elements actually made? And this is really, really interesting. So we have to step back and think about elements and atoms for a moment. So elements, they're like the building blocks for the stuff around us, right? The snow coming down, it's made of oxygen and hydrogen, but you can go smaller than that. So the smallest unit of an element is an atom. And atoms can be made up of 3 different particles. So in the atom, there's going to be the nucleus, the seed, or the center. And bare minimum, that's going to have protons. So 1 proton is a hydrogen. The number of protons in the atom dictates what kind of element it is. 2, you get helium. 3, you get lithium. And on you go, all the way to oganesson, right? And perhaps we'll synthesize new ones in the future. But that's where we're at right now. Now, past that hydrogen, there's usually going to be neutrons. So neutrons are neutral. So positive protons, neutral neutrons. Those are going to be in the nucleus, and they're held together by the strong force. Now, protons don't want to be together because they both have a positive charge. So with magnets, you've probably tried to stick positive side magnets together. They repulse, right? You can do the opposite. You can put a negative and a positive together just fine, but 2 positives, no. So that's what the strong force is doing. It's holding them together. So in a star, we get fusion when the star has enough heat and pressure to basically slam those protons together. And then some of them end up decaying into neutrons. Now, we should also mention that on the outside, there can be a cloud of electrons with negative charge. Usually those will match the number of protons, but not always. So to change the identity, we need to change the number of protons. But past iron, stars can't do that. So there's a trick, and this is where the weak interaction or the weak force comes in. What the weak force does is it changes the identity of our fundamental particles. So it can take quarks and change what type of quark they are. So it can turn protons into neutrons and neutrons into protons. So if we have really high energetic events, let's say supernovae or the collision of neutron stars, something like that, where neutrons can be bombarded, they can basically slam into the nucleus. Well, they can go into the nucleus because the electromagnetic force isn't going to stop them from doing that. Neutral can go next to positive just fine. But once they're in there, it's not going to be very stable. And the weak interaction takes over and decays those into protons. Now you've changed the number of protons inside of the atom, which changes what kind of element it is. So there's several different processes for how this happens, but that's the basics of it. Slam neutrons into the nucleus, they decay into protons, new element.